slides and the field slides.
Today is Exploring Dave's workshop tour. Let's go! This is Exploring Dave in his natural habitat.
Hello, good afternoon. I'm just clocking up a piece in my lathe to turn it down. I'm just on with building a motorbike at the moment, and this is going to be part of the filler cap for the fuel tank. So I've just made the fuel tank out of plate steel, and so later on I'm going to drill the hole in the top, and then this piece what I'm making will braze into the top of that, and then I'll cut a screw thread on this to take the filler cap itself, which I'll make out of another piece of brass. So just check that I always double check my chuck, make sure it's tight, and then there's no mishaps then. First of all, I'm just going to face it off. That's just facing off, just make sure the front end is true.
Have you ever left the chuck key in?
No.
Good.
No, it would make a mess if you did, but no, I never have. So I'm just going to set my depth to where I want it to stop, and I'm going to go about halfway down there. I made this gadget to knock it off at a predetermined position. So we put let's have a look, it's brass, so if I zero that now, we can put a 20 thou cut on that. That's 20 thou cut, so that's 40 thou overall. And then I can engage that, and that'll just merrily go along and that knocks itself off at where I've set it.
On this gadget that Dave made.
So I'll put another cut on, and then you can see it knock off. But I'll just put a smaller one on it won't squeal as much. Quick and simple.
Yeah, it's what we like.
So that's quick and simple. So
yeah, so that's that bit turned down.
yeah, so I'll have to change my gearbox wheels to cut a thread on that now, because I've got the wrong gearing in for that wants to be cut at 14 threads per inch. So I need to do. I've got the change wheels up there for cutting different threads, so I need to change them out, which it's not a 2-minute job, so we'll leave that for now. So other thing I was going to do was I've made the fuel tank, and I've got it sort of sitting where I want it, and reason I made a prism tank is I haven't got an English wheel or anything to make compound bends or, you know, curved angles or whatever, so quick and simple, flat and welded seams. So that's where I want it now. I'm going to put my filler cap at top there. So obviously I've got a little vent hole in there, because when you're welding it, it's alright while you've got an open end, but when you get to the last end, obviously the heat of the weld has expanded the air inside. When you leave it to cool down, then it will crush itself with the vacuum. So you need a vent hole if you're welding. So the next thing now is put on the drill press and drill it out. What I do is I use the lathe motor, and once that's running, that generates a 3-phase, and all I do is I just plug my drill into the lathe and I tap off that 3-phase supply. So it's what they call a pilot motor. So
that's the lathe fired up.
Turn my lathe on and then I can power my drill from it.
Nice.
Because that motor now is generating 3-phase.
Yeah.
And I'm just going to, with this hole saw, I'm just going to drill a small hole in there. That's that drilled out now, ready to accept my fuel filler cap.
Nice. And that's the lathe still running, because that was powering the biller drill.
That's
cool.
Now, so basically what I'm making is a stem that will sit in that hole. This is just a plumbing fitting, by the way, just to give you an example. That's going to sit in that hole, not quite that tall, and then the cap will simply screw on like that. So there you have it. So I'll finish turning that off and cut the threads, and then we'll probably have some finished photos of it.
Yeah.
Because it'll need to be brazed in.
You need to get all the bits out of there, yeah.
Get all the bits out.
Henry
now.
Hoover might be involved in that one.
Yeah, on a magnet on a stick.
Yeah.
Yeah, but we'll get that out.
Yeah. Shake it all about.
You know the score.
Yeah.
Yeah, so that's about all I was wanting to do today. We'll get this finished off. This is my welding bench. So I've got a MIG welder there. I've got a steel top on my bench, so that all I need to do, clamp my earth to my bench top, and then whatever I put on there is earth, and I can just get on and weld it, you know. You don't have to mess about clamping your earth to the actual workpiece. Makes it for a lot easier carry on. A bandsaw comes in handy for cutting big stock. Yeah, that's my frame so far, where I've got to. I'm just looking at this piece of bar here. I'm just looking at what height I'm going to make the sissy bar. The backrest, if you like, it's called a sissy bar. So that's going to attach these mudguard braces. That's going to attach to there, and I'm going to put a curve in it so it follows the mudguard to an extent, and then it'll come up to a point, and same at the other side. So I'm just toying with that to work out how high I want it. So probably about there, it'll be about right, I guess. It's only going to be a single seat, you know, it's just sissy bar for aesthetics.
Yes.
The frame, it's just made out of steel tube. The top frame is scaffolding tube. The axle plates, I've got some flat steel plate there, and I stick that in my bandsaw and I cut these blanks off of it. You can see how they sort of arrange. I'll put put my sort an angle and cut them. So then these two, I'll put them on my milling machine, mill a slot in it, and that allows the axle to go through for the back wheel. And then there's just simply welding the back of the frame there. The engine that's going in this is a Suzuki GSX 750. The back wheel is out of a GSXR 1100. The front wheel's a 750 wheel. I've got to swap that out yet. I've got the front wheel to go in here, but I haven't swapped that one out yet. So, because different disc patterns and everything, so I'll have to make spaces up and all sorts of bits and pieces. This is my pipe bender, and it's just an hydraulic jack, and you put your pipe in there and you jack up against it, and that's how
how you form these.
That's how you bend your tubes.
Wow. Yeah, it's not like 22mm copper, is it? Like scaffold pole and things.
You can't just bend it over your knee.
No,
So,
you just bend your knee.
yeah, in fact, I've got a bit of scrap here, so I think we can maybe. Can we get that in there? I might have to put this smaller head in, which is over there. Put me in shed in.
Sorry about the wobbly camera, it's quite hard to film in a garage.
And the action's taking place in here. So as I pump the jack up, you can see
It's pushing
the
against
follower's
that
just
collar.
pushing up against it, and it's bending the tube. And then
Yeah.
when we've got it to where we want it, so that's only a shallow bend, but you know, you just, what I do is when I'm doing one side of the frame, I'll count the number of strokes
Yeah.
on the jack, and I'll also take a measurement from the top of the frame to the top of the arc, so that when I do the other side, it's going to be identical.
Yeah.
This jig, what I make them on, both ends are extendable, so I can make whatever length of wheelbase I want. You know, I've made ones with 8 long forks in the past and things, but this is about where I want to be. It's fairly low. It doesn't look low at the moment because it's up off the ground, but if you think about, this would be ground level where I'm stood.
Yeah.
It's going to be like me, you know, low to ground.
Apart from when you're up some ladders.
Next job, once I've done the tank, is I've got some cardboard. I'm going to cut some templates out to make the electric box, which will sit in under here. That's going to be welded in permanent, and it also give a bit of rigidity to the whole thing as well. But then all the battery and electrics and everything will sit in there. The coils, you know, all that malarkey. So I've got a brand new chain for it.
Is that the rear sprocket?
That's the rear sprocket, yeah.
Nice. Is a front sprocket on the engine somewhere?
Yeah, that
Be in there, won't it?
that's the engine I was going to use originally.
Yeah.
But that's a GS 550. I've since got a 750 motor that I'm going to put in.
Is that because more's better?
I just had the chance of it. That were all, you know. And
Yeah.
yeah. This is pure air cooled engine, whereas the GSXRs are oil cooled as well. So there'll be an oil cooler to mount on the frame somewhere.
Yes.
I don't quite know. Normally they mount up top here, but what I'm thinking of doing is keeping it clean. I might actually mount it underneath
Oh yeah.
and then put an air scoop at the front
Yeah.
to flow the air through it and down and out.
Yeah.
So yeah, so that's either under there, or I might even fit it under here and still put an air scoop on.
Yes.
I haven't quite made my mind up yet. You know, that's one of these things that I'll get engine in and then, you know, throw things about and see where they end up. This is a an Addison 600 milling machine. At the moment I've got it set up with an horizontal arbor in for horizontal milling, and it's got a slitting wheel on. The last job I made was some slab yokes, we'll put a picture on, and this is to cut a very fine slot so that you can put some pinch bolts in and they'll actually clamp on the forks. So we'll put a picture of that on, and yeah, so they're a good versatile machine of these, bomb proof. The thing about Harrison's is it's an industrial machine and they used them in a lot of schools. That's where this came from, and the reason that's good is because they haven't had a lot of industrial use day in day out. You know, they've had very little wear, so they are a really good machine, and they're small, so they fit in people's workshops. There again, these are 3-phase machines, but each machine I've got a phase converter on it, and the phase converters I just use capacitors to generate the third phase, and you have a live and a neutral to one winding and an offset phase to your third winding, and yeah, it's quite a simple diagram. So we'll show you the converter. This one I actually made. This was the first milling machine I got, and it was purely horizontal. I didn't have the vertical capacity, so what I did was I made a vertical head. This is the vertical head I made for it. I'll put it on the bench and it's easy to see. And this just clamps.
Is the dog part of the...
Oh yeah, grommet.
Grommet's
yeah.
on it.
Yeah, grommet's part of the workings. So this clamps on the overarm, and instead of this spindle with this arbor with the horizontal cutter on it, the arbor runs through a couple of helical gears, transfers that rotation into that rotation, and then your cutters go in that collet chuck at the bottom.
Like a 90-degree gearbox.
Yeah, and that just sits on it, you know. So they're further back, like, you know.
Yeah.
Yeah.
Nice.
And
did you make that yourself?
I made all that myself, yeah. Yeah. The making of it wasn't the hard part. The hard part was getting it to run true to the bed.
Yeah.
Because it's no good it being slightly off one angle, either to the side or, you know, forwards and backwards. So I had to, well, hours and hours with the dial gauge mounted, trying to get it in, and you call it trepanning, getting it lined up with the bed. So, and then I got this other machine, which this is exactly the same machine, but it's got the vertical head attachment. I was looking for one of these to go on that machine, and they're like rocking horse poo are these, you know, you just can't find them. And I saw this machine with the attachment. It's got all the overarm and arbors to make it into an horizontal machine, but rather than swapping about, I thought I'll have one machine horizontal, one vertical, and then
Yeah.
ease of use then. So and then this, I fitted a digital readout on it, and it's makes it a lot more accurate as you know, as you're moving your X, Y and Z axis. This actually goes down to the micron, which is, I don't work to those tolerances. I only worked at thousandth. That's good enough for me, you know, for what I'm doing. Thousandth of an inch is plenty near enough, you know. But the thing with this is it's repeatable, because you can take it back to exactly the, you know, same, the last point, you know, the 0.
Yeah, which is a lot easier than an analog dial.
Well, you've got graduations on your dial here, and that's what you would use normally, work off of these dials. But you see, the thing is, it rotates more than once, so you've got to count how many revolutions, and if you get distracted and you forgot, You know, you can easily wreck a piece of work. The other thing is, with these machines, in the hand wheel there's backlash. There's that free movement. Whereas with the readout, that is the movement of the bed, not the movement of the hand wheel.
Yes.
So it's totally accurate.
The output, whereas the hand wheel is the input.
That's right. It's totally accurate. So I mean, you can take up, you can, you know, work in what the backlash is, you know. But why do it when you don't have to do?
So on a one industrial machine, chances are the backlash would be greater and
Yeah.
inconsistent.
Absolutely, yeah. You can alter it, you can tighten it up, but there will always be some amount of backlash. You know, they've all this. You see, there isn't much on this one, but and the knee. On this machine, the table goes up and down. On a lot of machines, Bridgeports and the like, the actual head, the quill, comes down, whereas this, the work moves up towards the cutter or away from the cutter. But they're a solid machine. They're solidly built. They weigh about half a ton, you know, so they're fairly easy to transport, and they come apart really easy, you know. They go at the back of a van. I've got an engine hoist, and that'll pick these up and put them in the back of a van. Really easy to move, really easy, and they're simple to work on. You know, the electrics on them, everything is simple. So, talking of electrics, this is a phase converter, and all it uses is capacitors. You have a pair of start capacitors that give it an initial kick. When you push the green button, it pulls in a start contactor that energizes the start capacitors, and it also energizes the run capacitors. It latches the run capacitor, and then when you let go of the button, the start relay drops out. The start capacitors discharge through the resistors, and it's left running, generating a third phase. Really simple circuit. No fancy electronics, you know.
Yeah, home rebuildable.
Yeah.
Home maintainable.
I mean, I built these at the time where inverters were fairly expensive, but you can get ones from China now with a dial on the side where you can, you know, turn the speed up and down.
Oh really?
Oh yeah, and they're really cheap now.
Wow, they used to be like pushing £1,000 before.
Absolutely, but you can pick them up for a couple of £100 now.
But,
So you know, but in the days when I built this, we didn't have that option. You know, it was really expensive to go out and buy a proper industrial inverter.
One eternity later.
Just to get where it wants to sit, because I've some lugs to weld on it yet. One at top there to bolt it onto the frame at top, and one at the bottom to bolt it onto the frame at bottom. But I'll do the filler cap first, and then I'll do the fuel cock, and then because it hangs down over the frame so much, what will tend to happen is, as the fuel lowers, you'll end up with some fuel in this side and some fuel in that side. And if the petrol tap's in this side, you won't be using that, so I'll have to put a balance tube across it.
Yeah, my motorcycle, I've got a BMW 1100 GS, and that doesn't have a balance tube, so you end up with one saddle full of fuel and you can't use it.
That's right.
So you have to go round the roundabout at just the right speed to chuck it over.
Yeah. So
Is that for your fork angle?
yeah,
Or the fork
because-
handles?
not the fork handles,
No.
because I've made it a longer wheelbase. Normally the rake would have been 40 degrees, but it's just 50 at the moment now, so you know it's it's not too long where it's going to be shaking its head a little bit. You know, like you see these big long choppers with massive forks. When you start tipping them, the forks want to fall over.
They want to fold in on themselves.
Yeah, they do.
Yeah, the TL1000S Suzuki had problems with its rake angles and things.
Plus, you have a big, massive turning circle with them.
Yeah, because you're only tipping against.
Yeah.
You're tipping against almost horizontal.
Yeah. So I think 50 degrees is nice. You still retain some of your handling, but you know, you get that effect of it being stretched out a little bit. But I can furnish you with the, if you want to, I don't know, it is previous bikes that I built. You can.
We're just repairing grommet.
Yeah, grommet fell off, so bit of silicone. That's it. Pump. Grommet is reattached.
Cool. We're back eating cheese before we know it.
We will.
Guys, want a drink?
Yes, please.
Oh yes, please.
Cup,
Sing
coffee, tea.
coffee for me.
Coffee.
And sugar.
Coffee, white, no sugar, please. Thanks, Pat. That was Pat. Exploring Dave's workshop tour. Thank you so much for watching. We'll be back to exploring videos on Thursdays at 8 PM UK time. Thanks very much.
And it's bye from me.
Bye bye.
See you later.
Looking over my shoulder, looking back at your door. In my head it goes over.